Hi, my name is Matt Maxwell, and I'm a product manager for Tektronix Spectrum Analyzers. And in this quick how-to video, we're going to talk about first turn-on of a wireless LAN device. And to do that, we're going to be using a Tektronix RSA607A. This is a USB controlled analyzer that's being driven from the SignalView PC software on this PC here. And I have my device under test here, so this assumes you have some sort of environment where you can either have a test port to connect a cable to the analyzer, or you may have to use antennas, maybe directional antennas on the analyzer with an omnidirectional antenna from the device under test, to have a reasonable assurance that you're getting good signal strength from your wireless LAN device. Also, in that kind of test setup, it's important to make sure that you're in a relatively clean RF environment, so you're not encountering interference from other signals over the airwaves. So let's get started. Here we start out with the instrument in a preset condition. Preset button, just like a regular analyzer, is on the front of the display, and I preset that to set the frequency. So in this particular case for the signal, I know that it's broadcasting at channel 1 of the wireless LAN frequency, so 2.412 gigahertz. And I right away am noticing that I don't see a signal present. So the reason for that is it's a bursted signal. It's not happening frequently. So the way that I get around that is I turn on a trigger, and I need to reduce the threshold, which I control when I bring up the trigger menu. I turn on the trigger, and then I reduce the threshold to a level where I'm actually capturing parts of the signal. So go down to about minus 25 dBm. So now I see updates, regular updates to the spectrum display, and maybe I also want to turn on a max hold trace in addition to the regular spectrum trace. So the blue trace is the max hold trace. So I'm looking at the power versus frequency of the spectrum from the transmitted signal. Now, the way this analyzer works is that a level trigger can be used anywhere within 40 megahertz real-time bandwidth. If I wanted to sweep wider to look for the signal, it may be more difficult. It's very helpful if you know where your signal's transmitting. And maybe future videos will talk more about using real-time displays to find the signal without a trigger. In any case, the next thing I want to show are some basic spectrum measurements. So I use the mouse control and I right-click to add a marker, and I want to look roughly at the bandwidth. I say roughly because I'm just positioning markers on the display, and I see the difference between those markers is 15.4 megahertz. If I go to something like a 3 dB down point, it's probably a little bit wider. So it looks like it's the right kind of signal that I would expect to see. 15, 20 megahertz or so for the wireless LAN signal. The spectrum analyzer has basic spectrum analyzer controls. Down on the lower portion of the screen, I can control the frequency. I can control the level with the reference level, which changes some of the gain stages in the analyzer to adjust the signal on the screen. As I increase that, it's overranging, or if I decrease that, it'll miss. It's always triggering now, but it'll get to a point where it's not triggering. And then I also have there it goes back to its other state. I have the span control. So I'm looking now at a 40 megahertz span of the spectrum, and then a resolution bandwidth or a measurement bandwidth filter. So the reason you may want to change this is if I want to look at wider signals, I see I have less resolution in the frequency domain, or if I down arrow to reduce the resolution bandwidth, not only do I have more resolution, but I start to be able to see further down into the noise. And it happens that the portion of the signal that I'm triggering on and analyzing is right at the preamble, so I see the pilots of the signal only. And that's one of the reasons why I see also a narrower bandwidth, less than 20 megahertz for this evaluation board. So these are important measurements to be able to make on a wireless LAN Internet of Things device for the first time the device is turned on. So I want to be able to look at rough signal parameters to make sure a spectrum is present and maybe perform some basic measurements. Just to take it a little bit further though, I have a number of other measurement capabilities available through the software. So if I select different types of displays, I can take a look at the same signal with the real-time display. So if I turn on trace 2, which is the peak hold trace, and I can right away see a burst that's been captured with the real-time display, and that gives me more insight. It also helps me if I'm trying to find a signal that is frequency hopping, changing channels, or make sure there's a signal present, which for a low duty cycle signal like this, that I might have a harder time seeing with the lower spectrum display. There's a lot more capabilities that we could use, but I think for first device turn on, these two are very helpful and powerful displays to help you make sure that your device is working correctly. Next steps will involve EMI pre-compliance as well as troubleshooting if things aren't working well, and then broader device characterization, which is another area that's more for the development of a wireless LAN module that goes into that final device. So we've looked at some of the high-level capabilities to perform basic spectrum measurements and some other capabilities that are available in the SignalView PC software for wireless LAN device first turn on. So I hope this has been helpful for you, and I thank you for your time.